Hi guys, today we have a plasma. This is an Insignia. It's a model number ISEDPLTV42. It's a 42-inch standard definition plasma screen from about 2005. As you can see, the plasma module is made by Samsung, and this one is totally dead. So we're going to troubleshoot and repair this set in this video. First thing we're going to do is we're going to blow all the dust out of the set. Oh, that wasn't good. We tripped the breaker. Drawing just a little bit too much power here. But on this panel, I have no idea what the problem is. It doesn't turn on. It doesn't click, it doesn't do nothing. So I'm thinking, we got a power supply problem. Now we've already got some caps that the tops have been blown off them here, so a good place to start on this is we're going to start looking at some of the capacitors and see whether the problem's in the power supply. Okay, we got this thing powered up, and I have one little LED down here that's lighting up, which is kind of telling me I may have some standby power. So we're just gonna test for some voltages. This is the probably shouldn't do that with it plugged in, should I? This is the standby supply. I think this is the standby supply on this, and we're just gonna measure some voltages. I see 5 volts here, and I got 5.2 volts. 5.2 volts. My standby voltage is there. This is interesting. I wonder. Let's go see what happens if I reseat this plug. Probably not a good idea if I do this with it plugged in. So we'll shut the power off. And we'll reseat this connector here and see whether it may have just been a connector that wasn't seated properly. Wouldn't that be the cat's ass? Okay, we'll turn that on. Now the set was totally dead, so interesting. When I plug this board in, it's killing this power. So I'm wondering if we maybe have a problem we have a problem in this control board here. Because this green LED went out when I plugged this connector back in. It's very interesting. Either that or my standby supply is low, which is also possible. My standby supply might be having a problem. It's kind of this glue out of here so that I can measure the voltage on the pins. I know I've got my 5 volt supply when I unplug this cord. Okay, I've now plugged it in and my standby light is lighting up. The set's not doing anything. Oh, what the hell? That set just turned on. I got power. I got power on this sucker. Not only do I have power, I got a picture. Holy smoke. Let's just hook this thing up and see if we actually get a picture other than just this panel lighting up. I've got a menu. Well, as you can see, I got the set working. This is not a high definition set, it's standard. I guess they call it an enhanced definition. But it works. I just got it on a closed circuit feed here on the tuner. I don't have the correct remote control for it, so I'm able to just pick up what I can get off of my in-house system. Even though the set is working, I know that there's still a problem with the set because I can't believe that it was as simple as reseating a connection, but I do think we probably have a capacitor in here that is getting a bit weak. This is the standby power supply, and this is the one I'm going to concentrate on because with the standby supply not working, nothing is going to work. So we're just going to disconnect these interconnect lines that go between the two power supply boards. I'm going to pull the standby board out. We're going to go through it and take a look at it and measure the ESR on some of these caps here, because I think that maybe we have a leaky cap. We're going to lift the board out and we're going to check some of these capacitors in the secondary side here for a high ESR, which would certainly cause the type of problems that we've been experiencing, or at least the set experienced. I mean, it might be as simple as a bad connector. That may be the problem, but again, we may have a problem with one of the filters in here going bad, so we're going to check that out. So we get the ESR meter, we'll zero out the leads, and we're going to test some of these filters in the secondary for a high ESR value. Here's our ESR meter. As you can see, I've zeroed it out. We measured the cap. 0.24, 0.27. Now 1000 should be no worse than 0.12. I'm going to change this one just because it is out of spec. And I'll show you what a new one, if I can find a brand new one, I'll show you what a real new 1000 microfarad 10 volt cap measures. So here we go. I got a new one. Meter's still on, still calibrated the same. 0.07. That's a new 1000 microfarad 10 volt. 0.07. And we look at this one, 0.26. So this cap is way out of spec, and it's higher than the maximum allowable for a capacitor. It may not be totally failed yet, but this one's certainly on its way, and that could explain why this thing's not working like it's supposed to. So we're gonna mount, I'm gonna put this original one back in because I think this one's okay, and we're gonna put this new capacitor in and put this thing back together and see what it does. Because the other ones are all well within spec. I checked these other caps and they're all way lower than what the worst case for a new cap would be. So I'm not concerned about any of the other ones on this board. This is the only one, or this one here I should say, this is the only one that was questionable when I measured in circuit. So I took the part out so I could test it out of circuit, and it failed. And I can show you. I'll run through these other caps in the circuit here just so you can see how valuable an ESR meter is. I mean, these things are just awesome. For the 70 bucks that they cost or so, you can troubleshoot a power supply in virtually no time. So I can just go across these caps here, you know, 0.3, 0.06, right, 0.06, 0.06, 0.02, 0.02, 0.26. This is actually a 100 volt, a 47 microfarad rated at 100 volts. For 47 at 100 volts should be 0.7. So we're at 0.26, so we're well below that. Again, 0.06. As you can see, all these other caps here, all tested fantastic. The only one that really gave me any suspicion was this one here, that came up at, well, now it's coming up at 0.3. 0.47, yeah, one. I mean, this is the one here that kind of drew my attention to it, because it was the one that was much higher than all the rest of the ones in the circuit. So that's the one we're changing, and we're gonna put the other one back in and put the board back in and see what this thing does. There we go, put the new cap in. One interesting thing to note on this set is that this board is obviously used in more than one chassis, because the standoffs, there's multiple holes for different standoffs for different sets, and you got to line it up so that they all line up with the standoffs on this particular panel. So this board was probably, this is a 42-inch panel, but this board was probably used on 50-inch and maybe even larger as well. One of the things I like about this set, and I think this is evident for anybody who saw the other plasma, which maybe I'll show you the difference. This set, this is a Samsung, and it uses discrete parts. It's not full of these big modular ICs like the LG set that's sitting next to me uses. And the fact that it's using discrete transistors for a lot of the high power components is probably going to increase its reliability. Like, for example, if I zoom the camera onto the X sustain board, you'll see the big modules here. These are discrete transistors mounted on these heat sinks. These can pack a lot of current. But you see, they're all discrete components. Now I'll show you the LG that's sitting beside me all apart, because there's a big difference. On the LG, the Z sustain and the X sustain boards, these are all in a power module IC, and those fail. They overheat and they fail, and that's one of the big problems with the modules. One of the things when I was in the electronics business that I really despised was companies such as Technics, Panasonic. When they, in their audio amplifiers, they went to big modular ICs that had everything in the IC. I hated it because the freaking things were so unreliable. They produce so much heat, especially when you get the teenagers cranking the stereo up. They produce so much heat that the module burned out. Panasonic weren't the only ones guilty of it. A lot of the companies did this. Sony was one of the first, and Yamaha, that went back to discrete transistors because they were inherently more reliable. And yes, they were harder to repair because you had to actually figure out which one was gone. With a module, you just change the module. When you got all these different parts, you got to troubleshoot down to the component level. So repair-wise, this is much more difficult to work with because you've got all these different components. But reliability-wise, because they're individual components, the heat is not generally as big a factor. So we look at this set here. I'll explain the components on here. You've got your X sus or X sustain board, your X driver boards, and these little connectors here, these go to the panel. These are where the panel all plugs in. You've got 8 driver ICs, your X sustain. Down here you've got your A board, sometimes called the ACOM or the A sustain. This drives the panel. That's your vertical drive, this is your horizontal drive, or vice versa. And this is the Z sustain board. This is the one that affects your panel brightness. In the middle here, you've got your power supply. This is the main power supply for the set. Generates the 165 and -70 and 175 volts, etc., for the panel. This one's the audio amplifier board. It's got your audio inputs on it. And this is your signal board. It's got your video inputs on it. The tuner, I think actually the tuner's, correction, the tuner's over here on the audio board. So this is your audio and your tuner board. And it looks like there's one video input on here. There's the component video inputs and the other inputs and the DVI connector. This has got DVI. I don't believe this set has HDMI. It's a little too old for that, but it does have DVI. Speakers plug into here, and this board just plugs into this power supply with these 2 connectors. One connector provides power to this board, and the other connector provides power to the other board. Okay, there we go. It's all back together. I'm just going to give it a once over here, and then we'll power it up. So I put on the power, and my 5-volt supply, it looks to be low. When I unplug this board, and I just unplugged the remote receiver to make sure it's not that. When I unplug the system board here, my power comes back. So I have a feeling that we may have a problem on this board as well. So I'm going to pull this board out and just take a look and see, maybe we have a cap that's going bad on here or something that's going bad on this board. Because when I powered that up, I was expecting the power to come up. And my little health light here only came up very, very dim. So if you look at the meter, I don't know if you can read that or not, 2.1 volts. This is my 5-volt line. And when I unplug this line, it goes up to 5 volts. So we have something on this control board that's loading it down. So what I've done is I've temporarily mounted the board. I just want to do some voltage measuring. So I'm going to go to the voltage regulator here, which is should have the standby 5 volts on it. We'll find that the standby is only coming up to 2.9 volts. So something is loading down the standby line. It's one of two things: either there's not enough current being supplied by the standby power supply over here, or there's something on here that's loading the standby supply down. Now, of course, the easiest solution to determine whether something is loading this down or whether it's the power supply is not putting out enough power on the 5-volt supply would be to substitute a supply for 5 volts. And that is easy to do with some batteries. So that's what we're going to do. I'm going to get some AA batteries. I'm going to make myself a little 5-volt supply. And we're just going to apply 5 volts to the standby regulator here. And if the set powers up, then we know that the problem is the standby supply is not putting out enough current. I still think something on here is loading it down though, only because the light is dim, and when I unplug the connector here, you'll see the 5-volt light here will go brighter as soon as I unplug it. If I plug this back in now, yeah, it loads down, you see? So something is either loading this down or supply isn't high enough. It's one of the two. So the way to find out will be to give it an external supply from a battery. Then if the set comes on, we know that it's not something on this control board that's loading down the supply. If we draw a lot of current from the battery, then we'll know something on here is loading it down. Probably a capacitor that is turned into a resistor. Okay, I think you can see what we're going to do here. I've got my 6-volt battery pack. I'll put on the power to the TV. Of course, nothing happens. So I'm now going to just touch the probe, which has got my 6 volts on it, to the input of my 5-volt regulator and see if my power will come on when I hit the power button. There we go. Oh, look at that. The TV just turned on. Part of the challenge of troubleshooting electronics, especially if you don't have a schematic, and I've never seen one of these designs before, is being able to kind of, you know, fly by the seat of your pants and figure out what's going on. I've stared at this a little longer, and I've just come to the understanding that the standby power supply is not actually this board. It's actually on the main board. This is actually the standby supply here. This is the supply that's always running. 5-volt line, this is the 5-volt health LED. Initially I was thinking it was fed back from this circuit, but it's actually not. And I was able to confirm that by unplugging this cable, this jumper. The voltage comes through, it's fed through over to this board, and then from here it's fed back over to the control board. And a little more troubleshooting, I find this diode right here. If I turn on my set, I'll see it goes up to about 3.2 volts. If I unplug, I don't know if you can see the meter there or not, but I'm getting about 3.2 volts. If I pull the plug here on my control board, it's going up to 5.21. So it's got me back to thinking that maybe the voltage is a little low. So we're just going through with the ESR meter. I'm just checking some of these caps out. And see whether I can find any that don't look right. Okay, that one looks like we may have a problem here. Just gonna get a closer look at this one. Okay, C8025. It's yeah, it doesn't look good. I'm measuring like 40 ohms across this thing. I've got it in the circuit. I'm able to get my probes on it. I'm not convinced that this is good. Well, this is in the regulation circuit. It looks to be on the oscillator. I'm on the primary side of the switching power supply, the switching transformers here, and this is on the primary side. There's a little capacitor here. I don't know if you can see it or not, but anyway, I'm going to pull this board out and we're going to check this one out of circuit. I might be getting erroneous readings because there may be some charge still in it. The power's off, but there may be some charge on here. I'm going to just pull this board out and we're going to check this cap, and replace it and see what happens. So as I continued to troubleshoot, I was getting kind of stumped a bit because it's hard to tell whether the reason my voltage is low is, am I getting too much current drawn through the standby supply from the control module, or is my power supply not putting out enough power? I was able to tickle using a set of batteries clipped onto the diode in the secondary, the power supply, which would bring the current up and the set would start. So it appeared that it was only happening on a cold start. Once the set was running, I could turn it on and off with the power switch and it would be fine. It was only after the power was unplugged and it was plugged back again that it wouldn't start. So that got me back thinking it's got to be a problem in this power supply. This is the standby supply here. This circuitry here, whoops. So this is the primary of the standby supply, and this is the secondary. So I was thinking it's got to be something in this power supply because the voltage is just too low. So with the aid of my ESR tester, and this was done totally in circuit, I didn't take anything out, I started checking some of my electrolytics on my primary side. And I got to this little bugger here. C8025. The green one. That's the new one that I just put in. This is the old one. When I measured it with the ESR meter, it measured really high. Now this is a 47 microfarad 35 volt cap. 47 microfarad 35 volt should be 0.68 ohms. You want to see how this one measured? Take a look. Here's my ESR meter. Hey, look at the display. It's open. I got the meter connected to it now. This cap is completely open. So, I know this cap's bad. I've just changed this cap. I haven't done anything else to the set yet. Yes, I did change a couple of the surface mount caps in the 5 volt supply inside the shielded cover. I changed a few of these little ones here because these things are notorious for going bad. So while I had it apart, I swapped out a couple of these caps. I changed all the ones on the 5 volt rail. There was like 4 or 5 of them. They weren't the problem. This is the problem here. So I've now replaced this capacitor. I've hooked up the wires. I have not turned on the set yet. I'm going to apply power. And let's keep our fingers crossed that it works. Oh, look at that. Look at that. Everything's on. You see our green lights? We have our 5 volt supply and we have our other power supplies. And if I press the power button on the remote control, it should shut off. There we go. The set's off. Our standby supply is up and running. This was the one that was dim before. Okay, that was the dead giveaway. This light was dim when I took my 6 volt battery and I connected the positive side to the diode here. We'll just put the meter on here so we can measure it. Oh, better make sure I have it plugged into the right meter. When I put my voltmeter on, it's measuring 5.2 volts now. It was coming up at about 3 volts. This is the side of the diode that I tickled with my 6 volt battery to bring the power up. And as soon as I did that, this green light went bright and the set fired up. Now with the capacitor replaced, the light is nice and bright And I pick up the remote control, press the power button. The set turns on. Let's see how our picture looks. Well, we have a picture. This is just coming off of my media player, so was downloaded off YouTube, so it's not the best quality. Let's try one of the other channels. There we go. I better not show this too long or YouTube's going to be getting upset with me. It's a commercial, but you get the picture. It's working. The TV's fixed. I got no sound right now because I haven't hooked my speakers up yet. But, yeah, this set is now fixed. Power off. Goes off. Power on. It's on and it's working. Now, the only thing that I'm not happy with, this set was given to me. Please don't do this to your plasma. Don't look at this. Look at this. You know, I don't know whether they took their Mr. Clean Magic eraser to it or what, but they've rubbed their anti-reflective coating off the screen. It just totally buggered up the bloody screen. So this is my set now. It's good enough for the garage. That's about it. I can't sell it. I can't even give it away because somebody's fucked up the screen. Anyway, it was just a challenge. Now you know how to fix an Insignia 42-inch. It's I'll put the model number in the video, but it's a Samsung panel. This is a Samsung set. So now you know how to fix one. And there's what the back of the set looks like. Here's our power supply board. And that capacitor C8025. That was the problem. Just before I conclude this video, I just wanted to show you the guts to this LG set that I've also got here. These are what I was talking about on the X sustain boards and the Z sustain. These are big power ICs and they're very common failures and they're relatively expensive, but they're not very reliable because they put everything into a big IC. They're hard to change, they're a pain in the ass, and they're not very reliable. Whereas, well, the Samsung, as we can see over here, they're using discrete transistors on this set. No output power ICs, just nice big heavy duty transistors. These things will never fail. The capacitors, on the other hand, well, that's a different story. Probably these guys are going to be the next to go on here because the tops are already kind of bulging a bit, and that's also a very well-known issue, very well-documented issue on these Samsungs. These big caps in the power supply have a tendency to go bad. So keep that in mind. If your set tries to start, clicks on and clicks back off, look at these guys here. If it just won't start at all, that's the little bastard there that caused the problem. Okay, hope you enjoyed, and again, the purpose of these videos is to help you fix your stuff and keep it out of the landfill. The more of these things we can keep out of the landfill, the better. Thanks for watching.